Good morning, and welcome to the Agroforestry in Action webinar series, a production of the Center for Agroforestry at the University of Missouri. My name is Gregory Ormsby-Morey, Education and Outreach Coordinator for the Center and host of the webinar series. Thanks for joining us today. Our topic today, high-resolution mapping of trees outside forests. And our speaker today is Todd Kellerman. Todd Kellerman is the GIS specialist at the National Agroforestry Center. He has a bachelor's degree in geography, GIS, from the University of Nebraska. Most of his work involves incorporating geospatial tools for agroforestry research. Specific areas of interest are multifunctional planning of agroforestry systems, variable width buffers for water quality, agroforestry mapping and inventory, and web-based mapping for outreach and technology transfer. The National Agroforestry Center is a partnership between the USDA Forest Service, Research and Development, State and Private Forestry, and the NRCS, the Natural Resources Conservation Service, and is located in Lincoln, Nebraska. So thank you, Todd, for being our speaker today. Following the presentation, which will run about 40 to 45 minutes, we'll then open up things for a broader discussion on the topic and field comments and questions from the audience. Please know that today's webinar is being recorded, as are all webinars in the Agroforestry in Action webinar series. You can find information about the webinar series on our website, the Center for Agroforestry website. That's centerforagroforestry.org. So you'll find information about the webinars, including the recorded webinars, available for on-demand viewing. Just go to the left side drop-down menu and click on the link for webinars. So I encourage you to visit the Center for Agroforestry website and see the range of agroforestry-related resources available there, including technical guides, training manuals, and planning and design handbook. And again, also links to the webinar series. So with that, it's my pleasure to welcome our speaker today, Todd Kellerman. Let's see if Todd's mic is active. Todd, are you okay?
Yeah, can you hear me okay?
Very good. Yes, thank you so much. So I'm going to mute my mic and while during the presentation, so please take it away.
Okay. Thanks, Gregory. Thanks for that introduction. I'm excited to be here today and share some of this work with everybody. Let's see. Okay. So the focus of this project is mapping trees outside forests and primarily in agricultural areas. And my goal for this presentation is to kind of tell you the story of these important landscape features. And not only are they important ecologically, but windbreaks in particular have kind of an interesting history as they relate to the Great Plains. So just kind of a heads up, I'm going to be talking a lot about windbreaks, also a lot about Kansas and Nebraska in particular. So here's a little bit what I'd like to go over today. I'll start out with some history of trees in the Plains states, maybe a little bit more than you want to know, but it's something I'm interested in, having grown up in the area. In fact, I grew up just a few miles from the site of the first homestead under the Homestead Act of 1863. And also, you know, a lot of us that grew up in this area, we've heard stories about the Dust Bowl firsthand from our parents and grandparents. So just interested in that history. I'll go over why we're doing this work and some of the methods we're using to map these trees. I'll briefly talk about the status of the project, as well as some future directions and ideas that we have. And partnerships are a very important part of this work, so I definitely want to point some of those out. So there's two distinct features, what's defined as a plain, flat and mostly treeless. The boundary of the Great Plains has been defined differently throughout the years, but generally entails this area on the map on the left there. And the map on the right is a map of forested land in the US. So the bulk of our work is in the four-state region of the northern plain states of Kansas, Nebraska, South Dakota, and North Dakota. And my apologies if you've heard this joke before, but this is in fact not the state tree of Nebraska. So historically, most naturally occurring trees growing in this region occurred along riparian areas. And this excerpt from a article called A Long, Long Time Ago, we can read, it says, by 1900, most of the trees and other woody vegetation along the rivers and streams in the Great Plains had been cut and removed by Indians, gold seekers, soldiers, railroad crews, and settlers. These riparian zones were once heavily forested with wide bands of trees, but are now occupied primarily by herbaceous plants or cropland. So there were also some federal policies that kind of changed the landscape. Of course, the Homestead Act brought people to the area with the promise of free land. There was a Timber Culture Act of 1873, which granted additional land to settlers with requirements of planting 40 acres of trees. And this program turned out to be largely unsuccessful and was repealed in 1891. So there's, you can see a picture of a sod house there, which was a fairly common sight for homesteaders in this area. And prior to the invention of barbed wire fencing, major use of timber was for fencing to keep livestock contained. And with the lack of timber, hedges were sometimes used for this purpose. Osage orange was a popular choice for living fences. And here's a map showing the prevalence of these hedges on the Midwest prairie around 1880. So moving forward to the 20th century, most of us are familiar with the story of the Dust Bowl, a series of wet years preceding years and rising wheat prices led to intensive cultivation of increasingly marginal lands. And with the onset of drought in 1931, the overplowed farmland began to blow away. Massive dust storms and economic devastation ensued. And you can read here from Black Sunday, which was in April of 1935. This storm carried twice as much dirt as was dug out of the earth to create the Panama Canal. The canal took 7 years to dig. The storm lasted a single afternoon. More than 300,000 tons of Great Plains topsoil was airborne that day. That is from The Worst Hard Time by Tim Egan. So you can see also some other photos here, just what that looked like. So in 1933, President Roosevelt started a series of New Deal programs to lift the country out of the Great Depression. One of those to combat these severe erosion problems was the Prairie States Forestry Project, which was targeted at two major challenges, unemployment and wind erosion. With plenty of resistance from both scientists who didn't believe trees would grow in this region, as well as politicians, the project did proceed. And from 1935 to 1942, the Civilian Conservation Corps and Works Progress Administration crews planted more than 200 million trees across 6 states. Over 30,000 windbreaks were planted, which equated to about 18,600 linear miles. You can see on the map on the right there, the area's concentration where those windbreaks were planted. And the photo of the gentleman in the center is Raphael Zahn. He was the technical coordinator for this project, and he was the first chief of Forest Service Research. So interestingly enough, the headquarters for the Prairie States Forestry Project was in Lincoln, Nebraska, and much of the original documentation from that project ended up at the National Agroforestry Center. So I wanted to just talk a little bit about some undertakings that we've been involved with to archive some of this material. Thousands of photos, hand-drawn maps, and other materials are currently being digitally archived by partners at the University of Nebraska. A significant contribution by our now retired research technician, Richard Carmen, was to digitize some of these old maps where the original plantings were located and rectify that data using current aerial imagery. So here's kind of what some of those old maps look like, some of the information with those, some of the photos from that time with some really great captions that give us some insight into this time period. So one thing we could do with this data is kind of look at what's happening out there on the landscape since these trees were planted. So this shows how we take those old hand-drawn maps. We can identify the same area on aerial imagery and digitize those windbreaks. This allowed us to determine the status of the original planting locations. And while there may have been new windbreaks planted in the same location in the preceding years, we know where those sites were and what is there now. And so this table in the lower left shows the status of those sites between 2003 and 2016. So a little surprising, we can see that a majority of the windbreaks sites still have an intact or partially intact windbreak. And percentage of those removed increased over this time period. And again, these are the sites of the windbreaks that were planted in the Prairie States Forestry Program in the 1930s. The aerial imagery in the lower right there with the arrows kind of shows a partially removed windbreak. So this is a map of Nebraska that shows all the locations of these original planting sites and the year they were planted for Nebraska. This map and data is actually an interactive map within a story map that we've recently published, where you can explore the data a little further, and I'll talk about those story maps later on in the presentation. So we talk about monitoring change or trends with easily available aerial photography. We can look at the landscape and see what's going on. Here's an example. This series shows the same fields over a 3-year period. You can see about 33 acres of trees were lost there. And those who may not be familiar with the landscape here in this region, those circles on the fields are center pivot irrigation. Here's looking at a different time period from 2006 to 2016. You can see the dramatic effect that center pivot irrigation has had on a lot of these windbreaks. Most often the windbreak is partially removed in the center sections, leaving like an L-shaped pattern in the corners. I'd also like to point out on this one, there is some new windbreak plantings by the red arrows you can see there, protecting, looks like some farmstead and some sort of buildings. And this time period that I have here is also significant due to some major events related to agricultural production. There was the implementation of biofuel standards, which led to more interest in corn planting. The price of corn was high during this period. There was also a pretty dramatic increase in ag land values. So just for example, here's a chart of the corn prices during this same time period. So there's definitely some external forces going on that may contribute to the changes going on with these windbreaks. Here's another example going back a little further in time from the 1950s to a recent one. And there's a variety of reasons that have led to the changes in these agroforestry plantings. Some examples: changes in farm machinery and farming technology, as well as changes in conservation technology, crop price fluctuations, conservation program changes, the aging and the aging of the original plantings, just trees naturally dying. There's the increases in non-operator landowners, as well as the irrigation practices, which you could easily see. So just to name a few of these things that have all had an impact on these resources. This map shows changes in irrigation from 2002 to 2007, and you can see a tremendous increase in irrigated acres, the blue dots, especially in Nebraska. There's about 55,000 center pivots in Nebraska. So I showed you a little bit about the Dust Bowl earlier in the 20th century. Let's bring this issue up again, and this was from last year here in Nebraska, not far from Lincoln. And reading from this news clipping, it says, on successive days in April, dust clouds from farm fields along Interstate 80 triggered chain reaction crashes. The first day, a 29 vehicle collision left 1 person dead and 15 injured. The second day involved 11 vehicles, but no one died. The state patrol said visibility was reduced to nearly 0 the first day. The weather played a role in several ways. An unusually cold, dry April, the second coldest on record for that state, had thrown farmers behind in planting. Near drought conditions parched the soils. At the close of April, southerly winds ushered in warmth and farmers hurried into their fields. Those same winds kicked up billowing clouds of dusty soil. In one instance, the cloud was described as a 100-yard wall of thick dust. And you can see some photos from that, the sign on the interstate there giving the warning, blowing dust ahead, slower speed advised. This is just an image from earlier in 2018 showing GOES, which is a satellite picking up the dust blowing. This is more in Kansas. You can see the pink streaks are the dust blowing. And that the previous storm in Nebraska led to the first ever dust storm warning declared by the National Weather Service in Nebraska. And here's just a few articles, newspaper clippings talking about the issue. And it wasn't isolated just to Nebraska, and there's photos from South Dakota here as well as Oklahoma. That you can see the article in the middle on the top. It talks about the debate continues on how does slow winds limit erosion, and then a couple of articles from Scientific American, Popular Science, with kind of some catchy headlines. Dust Bowl days are here again, and we're barreling towards another Dust Bowl. These are a few more articles touching on the subject of tree removal, indicating that these resources are under threat. So I'm not here to claim cause and effect, but if you look at some of these articles, read some of the comments, that sort of thing, people are definitely having those conversations. And so why not throw in a little bit of flooding too? This last year was, we saw record flooding in Nebraska. Of course, this part of the country, we're familiar with harsh weather. But I point this out mostly because as extreme weather events and weather variability under changing conditions become more common, these incidents may not be as isolated as they are now. I also wanted to highlight this assessment, which came out in 2017, a broader perspective of agroforestry, but it provides a synthesis of the use of agroforestry for mitigation and adaptation services in the face of this climate variability and change. So from the Nebraska Forest Service's historical book that they released recently, a Fremont lawyer was quoted saying, "It is my opinion that in the future, the residents of Nebraska will be very happy that someone was farsighted enough to construct these shelter belts." Well, in the photo down below, in 2017, Nebraska's first windbreak was removed by a new landowner. And the picture, there was a historical marker there noting this, and the picture of the trees there next to the landmark is just very striking. It elicited a fairly strong response in some circles and from the locals. And there was text on this marker that read, "The area closest to the roadway will remain unaltered as a living reminder of the Prairie States Forestry Project and the efforts of Nebraskans to protect our valuable farmland." So, and being the good geography nerd that I am, I had to go and check it out myself with some aerial photography. So you can see where that blue line is going on the west side of the road there is where the marker was. You can see a little bit of a pathway there we could drive in. So that's what it looked like before, noting that it had already been partially removed, obviously, and this is what it looks like now. So yeah. But from an inventory perspective, we ask, do these anecdotes add up to any trends and what's really going on out there? And it turns out we don't have good information about these trees outside forests for us to declare any factual statements. We hear a lot about windbreak removal. We see it with our own eyes, but we need to be a little more systematic with our assumptions. And I also wanted to point out there is, in fact, some evidence of increasing windbreaks for certain counties in this region based on some preliminary work we did. There appeared to be some hot spots where windbreaks have increased. But this kind of leads us to wonder what's going on at maybe a county level why is this happening? And just another question that we hope to be able to answer in the future. So moving on, I've pointed out some instances where the inventory of these trees would be useful, but we need the data. From a USDA perspective, this project fits within the agency's strategic goals, which were enacted in 2018. Strengthen stewardship of private lands through research and technology. The bulk of our work does fall primarily on private lands. We can enhance conservation planning with science-based tools and information. This information is useful for conservation aid agencies, policymakers, and land management planners. It's also useful for targeted conservation efforts to address natural resource challenges. The recently updated USDA Agroforestry strategic framework also calls for advances in agroforestry by establishing inventory and monitoring of these systems. So we recognize we're not working with all types of agroforestry with this project, and the area is limited to the Central Plains states. But there is a need to understand the extent and function of these trees. And this high resolution mapping that we're doing is a first of its kind at this scale and in this region. So the impetus for this work goes back several years. There's always been a question surrounding agroforestry is how much is out there? And while there's been some work done in the past, no large-scale coordinated inventory has been done, and neither the Forest Service's or NRCS's natural resource inventories capture these trees outside forests. And this lack of accurate inventory hinders the ability to estimate and project the magnitude of the ecosystem services these resources provide. So these are a couple of documents I highlighted here that talk about the need for accounting for these trees. A key finding from the report on the right, assessing the sustainability of agricultural and urban forests in the United States, says that, quote, inventory and reporting activities are sorely lacking for agricultural and urban forests at the national level. The publication on the left from 2005 details inventory gaps and estimates the proportion of trees that are missed by current inventories. So this map shows those estimates, and these are proportion of trees not inventory based on FIA definitions. FIA is the Forest Service's Forest Inventory and Analysis. I'll talk about that a little bit more in a minute, but their sample-based approach just doesn't work that well in this part of the country. So you can see around 50% is potentially being missed and upwards of 70% in North Dakota. So besides knowing how much is out there, knowing where it is and the function of these trees is very useful information. Sample-based approaches to inventory don't tell the complete story. And there are national scale data sets. There's the National Land Cover Data Set, or NLCD, which is a low to medium scale resolution, but it often misses these small tree patches, which are common in this region. You can see here, and this is an app in a story map that we've created, where you can, it shows a difference between the coarser resolution and the data set that we've created. And you can see many of these linear features, which are windbreaks, just aren't picked up. So you can't fix what you can't see. So enter our project TOFI. That stands for Trees Outside Forests Image-Based Inventory. This was started with support from the Forest Service's FIA unit at the Northern Research Station and the National Agroforestry Center. We have two phases to this project. The first phase is to develop the methods to map these trees outside forests. And then the second phase was to identify and quantify some ecosystem functions that they can provide. So we want to create this baseline inventory that can be monitored over time, as well as fill in the gaps of current inventories to extend accounting of these trees to all lands. The publication shown here from 2012 describes the initial methods that were determined to be effective for our mapping efforts. So I mentioned a little bit about the FIA program. It's more suited to traditionally forested areas with their sample-based approach. And so this is kind of how we've based our definition of trees outside forests, based on their definition of forested land. So for FIA inventory, the area that must meet the criteria is being greater than 10% canopy or greater than 1 acre or wider than 120 feet. Many of the working trees in agricultural areas just don't meet these criteria, and they're not being accounted for. Getting into the methods just a little bit. We use what's called an object-based image analysis, and this simulates groups of objects on the landscape. Typically, when you classify remotely sensed data, it's done on a pixel-by-pixel basis. But this method creates cleaner-looking maps. So we use kind of some minimal training data that identify features that we want to classify, and then an algorithm identifies those features. And the resulting output is a high-resolution GIS data set that's 1 meter in resolution. And we do not do any type of tree species information. So the process starts with the image segmentation. And we use a software called eCognition. So it segments the imagery into what's called image objects, which are basically polygons, which identify areas of unique features. So we use that training data paired with some custom tools that we developed in ArcMap and running an R script of random forest computer learning algorithm. And we use NAPE aerial photography, which is the National Agricultural Imagery Program, which is a FSA product, I believe. So these data sets, they're publicly available, frequently flown, and they're wall-to-wall coverage for a state. They also are 4-band, so they include a near-infrared band, which helps identify the features. So this is kind of what it looks like going from the raw aerial photography to our final output. The green is the tree cover there, and unfortunately, not all of our output look quite this good when it comes out. We do some light editing to make sure the output is classified correctly. And the methods that we've developed are they're applied to this type of landscape of agricultural areas, so they may not work as well in, say, like urban areas. Just some facts about output, and this is a map of what that data looks like. We work on a county basis for easier data management, both on our end and for the user. We've tried to minimize output file size, which is a 4-bit raster TIFF file. And for example, the final the entire output for Nebraska is only about 3 gigs big. And for Nebraska, we processed about 200 million pixels. So this chart here compares the land area of trees using our methods compared to some other data sets or inventory. So this is Antelope County in northeast Nebraska. And FIA defined as forest land estimated about 8,300 acres. Our estimates using the high resolution mapping methods came up with about 27,000 acres of tree cover. And using the lower resolution NLCD data set, depending on which classes you use, just using forest classes came up with about 12,000 acres, and including woody wetlands class, about 23,000 acres. So this is kind of combining our final product for Nebraska and Kansas, which is currently the two states that we have a complete data set for. Nebraska was using 2014 imagery, and our estimates show approximately 600,000 acres, an additional 600,000 acres of trees outside forests. And for Kansas, which was using 2015 imagery, an additional 1.3 million acres of trees outside forests. So I mentioned phase 2 was using our data sets to determine tree function using some shape metrics. So like riparian zones and windbreaks typically have distinct shapes. Can we identify those features based on the shape alone on a large scale? This graph is from a paper we published in 2017. Don't need to know the details of it, but we determined you could classify these groups based on an index we came up with called the Straight and Narrow Feature Index. And windbreaks were also broken out by direction, so like north, south, east, west, as well as L-shaped ones. So we're currently working on classifying those shape-based data sets for Kansas and Nebraska. This is an example of what that data would look like for a county in Kansas, broken down by the type in the table there. I have a few more categories there, the trees outside forest category. So for example, there's about 5,000 acres of trees defined as riparian based on the shape. A complex windbreak, you can see there is one in which several segments going different directions are linked together. So our hope is to also use this data with other data sets, such as the cropland data layer, which is a NAS product, National Ag Statistics, Survey Statistics, I believe. It's a lower resolution product, but it's updated annually. So we can use this to add more context-based analysis with our data. So this shows that not only knowing how much is out there, but where it is can be so helpful. We also hope, besides state forestry agencies, that other state and local level managers, conservation planners, and decision makers will find this data useful for planning and conservation efforts. So kind of looking ahead, what we're working on now and potentially in the future. So we've got our initial data sets completed for Kansas and Nebraska. What are some next steps? Well, we hope to publish the windbreak and riparian data sets once they are complete. We've also done about 75% of another statewide data set layer for Nebraska using 2009 imagery. And North Dakota and South Dakota are nearing completion for their first statewide maps. And I believe Kansas may be doing another year for the statewide map, and they are also doing some urban forest mapping, I know. So we realize that we need to do some more robust estimations in order for this data to truly be considered, for inventory inclusion. Just adding up pixels probably isn't going to cut it. So exploring opportunities with partners, incorporating some types of field data or something like that. Like I mentioned earlier, also being able to use this data for some value-added analysis, incorporating other data such as that cropland data layer. We feel this data can be useful for people doing a wide array of issues dealing with water quality, wildlife, pollinators, or other related topics. We'd also like to see a shift towards being a consumer of other people's high-resolution data sets instead of producing the data ourselves. Private sector data is coming online, which could be purchased. We also see as more things come online in the future, maybe there'd be some free data, and then we're not creating that task of creating the data sets. In the meantime, pushing our mapping to the cloud would definitely be more efficient. For example, Google Earth Engine would be one thing we've explored a bit. So here's a couple examples, applications that the data set is being used for or could be used for. The first one is Kansas is undertaking currently. They're using the data set with some additional information to reach out to landowners to let them know about possible cost share or other conservation programs available for windbreak renovation. And sounds like they've been pretty successful with this work so far. The other example, you could identify riparian zone gaps for water quality or wildlife concerns. You could prioritize these gaps in existing tree cover to target conservation efforts, and being able to do this at a bigger scale, be more efficient. Instead of just, you could do it now at a small scale, but using our data set, could scale that up. We're highly interested in quantifying some of the ecosystem services that these resources provide. One example is accounting for carbon sequestration benefits. Work's been done in this area, but being able to quantify based on acreage could be useful. Some additional modeling, such as incorporating LiDAR data, would probably be necessary to enhance the data that we've created. The graphic on the upper right is work currently being done by partners at Kansas State, showing how windbreaks affect crop yields. And again, this work could be scaled up, knowing how many windbreaks are out there, and the acres of ag fields adjacent to these windbreaks. So based on some initial results, using our shape-based methods to quantify windbreaks only, this map shows just the windbreaks in Kansas. And these are some early estimates, and they definitely need some more QA, but they show about 30,000 linear miles of windbreaks for Kansas in 2015. This is what that looks like, zoomed in a little bit. And so here's a map showing windbreak length for county. As I mentioned before, being able to quantify the area protected by windbreaks would be great. Based on these results, there's about 900,000 acres protected by windbreaks in Kansas. And making some generalizations with the data here. So again, we could add in some other data layers like cropland data to get more information about what is being protected, how much of the windbreaks are protecting farmstead versus fields or pastures would be another example of using this data. Same thing for Nebraska, estimate about 17,000 linear miles of windbreaks for 2014. And here's the county map, windbreak length by miles. And again, these numbers, using some generalizations, for example, we don't have tree height, it's not part of our data set. But this shows an estimate area protection by windbreaks of over 518,000 acres. So talking about kind of future of this work in general, some things we've kind of explored, new technologies coming online, which can speed up the work, as well as expand on what's out there now. Cloud-based computing using tools like Microsoft AI for Earth or Google Earth Engine could reduce the processing time to next to nothing. Esri's expanded their raster-based tools, making land cover classification easier. So using deep learning versus machine learning, which is what we did, and the expansion of remotely sensed data, both public and private, I feel like we'll usher in just a new era of land cover and land use mapping and classification. I can foresee in the future going and downloading a current high-resolution land cover data set for anywhere in the world with the ease that we can, download aerial photography nowadays. This clipping from the Microsoft Green blog talks about mapping a national land cover map in 10 minutes, which is great. But it also makes me a little sick to my stomach knowing what it took us to map one state. Granted, they've got, you know, the platforms and the hardware to do this, but they make a great point in the article, pointing out that the best national land cover data set for the US is the NLCD data set, which I was showing earlier, is 30-meter resolution and almost a decade old. So it's kind of crazy to think about that. And I think there's just a lot of potential, and I think we're going to see a lot of expansion in this area in the future. It's also worth noting other agencies are creating data like this that may be available if you're interested in other areas of the country. The Northeast, what started as part of the Chesapeake Bay program, the Chesapeake Conservancy has mapped quite a bit of area beyond the immediate area of the bay. NOAA has also done quite a bit of mapping with their coastal change analysis program. This map shows some of the areas that they've done. So talking about partners, which have been just critical for this project, none of the data creation or mapping would have been done. We just didn't have the capacity to do that. So I wanted to give a shout out to Dacia Meneguzzo. She is a research forester with the FIA group at the Northern Research Station in St. Paul. She is the PI for this project. Greg Lickness, he also was a researcher with that unit, was instrumental in getting this project going. He developed all the tools, and his vision for this project was paramount. He's unfortunately no longer with the Forest Service. And the Kansas Forest Service, their GIS specialist, Darcy Paul, has been a great part of the team. So here's a list of those partners that we've been working with and some of the status of the mapping. Some of this work's been in conjunction with some funding from state and private forestry of the U.S. Forest Service, with their goal of quantifying the location and condition of windbreaks to engage with landowners. And so, and some of these estimates for North and South Dakota for the progress may not be quite up to date. So some output products that we have done. So the data sets for Nebraska and Kansas are available on the Forest Service Research Data Archive for download as a GIS layer by county. Kansas is on data.gov, and in the future, the other states will be as well. The data is also available in what the Forest Service has a raster data warehouse that we can link the data to directly into like ArcMap and use the data from there. And the data is or will be on ArcGIS Online for easy access to it in the future. We've also created 2 story maps, which are a great way to engage folks about the project. I'll talk about those in just a minute. Here's just a few articles and other media that have come out about the project. The AP picked up an article about the project from the Bismarck Tribune in 2017. And so I was seeing that popping up in various newspapers around the country. So this is one of the story maps that we recently published. This one is named Making Trees Outside Forests Count. And it's just kind of an overview of the Toffee project. It includes some examples of how the data is being used. It has some nice interactive maps highlighting the data. This is one that's titled Windbreaks of the Great Plains, and we just released this a couple of weeks ago. And it really just kind of tells the story of these trees and some great graphics about how windbreaks work, some of the photos from our archives, and there's also a entire section of mapping different maps where you can explore our high resolution data set, as well as some of that Prairie States Forestry project data with the windbreaks that I was showing earlier. And we are also working on a ArcGIS online web mapping application that would be publicly available. So this is where you could go to explore the data. We want to combine some other publicly available data sets as well as some tools that the user can use to view and interact with the data. You could create maps of areas of interest, that sort of thing. Because right now the data is available, but it's in a GIS format. So unless you're GIS techie, there's no way to really kind of view it and interact with it. So we think this is going to be a great tool to do that with. And I was going to open up the map just to kind of show you what that looks like. So hopefully it comes up here and you can see it. So here's the Kansas and Nebraska data sets. Kind of interact with it. Hopefully it's not lagging too bad. But can zoom in and out. There's other data sets that could be useful. So here's that. Well, here's some soil erodibility factor. So you could incorporate some soils data for analysis. The cropland data layer that I was talking about. Oh, there, it's going to come up maybe. And what that looks like, and I'll let me show you. Let's see. So one of the tools that you could do is go in and create buffer. You could add in a stream layer and create your own buffer using whatever width that you want. It creates a separate layer in the map, so you could go in, set a 50-foot buffer on streams, check out areas of riparian areas where conservation efforts could be targeted. So here is some of that Prairie States Forestry Project data, the windbreaks, the linear, green lines on there. You can see that cropland data layer a little bit better up here. So there's the legend, maybe you can see. Of course, everything's primarily green or yellow, corn or soybeans, and next year they will be the same colors, but in different fields. But again, that's something that's updated annually. Here's the first windbreak site that was removed that I showed you earlier. The base layer for this is still a little bit older, so it's still showing up there. But yeah, just kind of some cool things I think you can do with it. Just let people explore the data a little bit, get a better idea of just maybe get some ideas of how they could use this data. So now I will go back and wrap up my presentation. Maybe. So this is our website. The Toffee website is housed at the Northern Research Station of the Forest Service. It's got links to data, publications, partners, all that relevant information. And then I also wanted to point out the National Agroforestry's website. If you haven't been to it lately, we have a new new website, and it's really cool and very user friendly. So definitely check that out. And there's an inventory section on there. So with that, that's all I have for my presentation. So I guess if there are any questions or comments, I could take those.
Sure. Thank you, Todd. This is Gregory. Thanks everyone for participating, and thank you to Todd for the presentation. We do have time for some questions and comment, and a little bit of discussion. So what I'm doing here, if you'd like to send in a question or a comment, please notice at the bottom of your screen, if you drag your cursor down, you'll see a little icon. It's the chat, it's a little bubble with chat. Just click on that, and you'll be able to write in any comments or questions. So Todd, while folks are sending in some questions, perhaps we'll get started. I see one question that's come in from J. Ellen Wood, and just to reiterate that yes, this presentation is being recorded and will be posted on the Center for Agroforestry website for available for future on-demand viewing. Once again, thank you, Todd.
Yep.
I'm really curious that I've noticed that the initial mapping, I guess, is a long and arduous process, but that initial mapping coming largely out of the Northeast. And I think you mentioned it was coming out of some of the Chesapeake Bay Initiative, some of the consortium around the Chesapeake Bay Initiative. Is that work continuing, or have they actually completed or no longer doing that kind of mapping for the Northeast? Just so I'm clear on where they're at with that.
Yeah, I don't know all the details. They are, I believe, still mapping areas up there. I know the University of Vermont is doing a lot of the mapping for that. You know, I think last I checked, you know, they had well, I don't want to say for sure, but yeah, that is continuing. I think if you go to the Chesapeake Conservation or Chesapeake Conservancy, I think they have some information on there, or at the least some information to partners that are still working on that. I know that I believe the University of Vermont is a partner with the U.S. Forest Service doing some of this, and I know they're doing you know, their classification outputs probably are more classes than we've done. And they're also involved in some urban forestry mapping too.
Okay, well, yeah, thank you. I'm interested, very curious to learn more about that, and I'll try to explore that with some of the partners there and learn more about it. There is one question, Todd, that's come in from Juliet Grimaldi, and concerning the methodological aspects for classification. And she writes, could you please tell us more about the pixel by pixel approach you have also have experimented, and what are the pros and cons of both object-based and pixel approaches? Are you able to respond or break down that question?
Yeah, so I guess traditionally when you use remotely sensed data, which aerial photos or satellite imagery, classification is done on a pixel by pixel basis. And so, not that that's bad, but what you often end up with is kind of like what I'd call like a salt and pepper looking type of output. Our methods with the object-based image analysis tries to group objects how a person would visually see them on the landscape. And so, I mean, the goal is to get a little bit of a cleaner map, or a cleaner output instead of that kind of pixel by pixel. So I don't know if that answers the question fully, but that's kind of how I look at it.
Okay, thank you, Todd. Yeah, as we're waiting for any other questions or comments to come in, I guess one curiosity I have, if I can express it, right, is considering this work that you're doing and developing this inventory and the tool, as we maybe talked about in the beginning, the work that you, or the landscape that you've been looking at for the most part has been windbreaks and such, or riparian boulders with by and large a pretty clear linearity. Is there any considerations or any advice that you would have if, say, someone working in quite a different landscape wanted to adapt this or a different tool for similar kind of inventorying of trees outside of forest? It would say in a landscape that was very dispersed, much more dispersed than intermittent trees, but outside of what would be considered forest. Is there any consideration or advice you might have on that?
Yeah, I mean, yeah, the methods could be applied anywhere. Probably the difference would be finding that right balance of that segmentation that I talked about. If you have too much, you get, I mean, it could go in and do, individual objects, but then you end up with just like too much, and training the data and that sort of thing would be hard, not to mention the size and that sort of thing. I guess, yeah, the challenge is kind of finding that balance of not segmenting out every little detail, but yet getting enough useful objects that you can use to get, what your goal is.
Thank you, Todd. Hoping we might see some more questions. We've got a few minutes, and if any of the folks still with us, any of the participants still with us, if you have any questions or comments, please do try to open the chat box and send them this way in the couple of minutes we have left. I guess one other question I might have is, Todd, is when you and the colleagues you're working with were starting out on this, were there any other examples from around the world of efforts to do something related or similar that were a good source of guidance or were instructive for you as you began this process? Yeah,
I mean, there are several countries around the world that include trees outside forests in their forest inventories. And so, I mean, the United States is unique in its size, and so the scale of the scale there's different issue.
Right.
But yeah, it's not a new thing if you look at what other countries are doing. The methodology, can't speak to that too much of what they were doing, but I think when we first started on this journey, using the image segmentation and that sort of thing was relatively new and innovative way to do land cover classification. And I wouldn't say that's the case anymore. It's definitely becoming more common. I think some people are familiar with that terminology more than used to be, and that sort of thing. So, but yeah, I mean, there's definitely, other countries are doing this work, and I spoke about the work being done in the Northeast with the Chesapeake Bay program. They were doing this work, I believe, before we were. But again, we're from an agroforestry perspective trying to do it in agricultural areas, and no one else is all that interested in doing those yet. But I think, like I mentioned too, I think in the future we're going to see, we're going to see these high resolution land cover maps available, just for the whole country, and just more accessible.
Okay. Well, Todd, I'm not seeing any additional questions come in, and we are already past the hour. So I think we can bring things to a close right there. And so I thank you very much for an excellent presentation and all the hard work.
Yep.
And want to also thank all the participants who joined us today. And so once again, this has been a presentation in the Agroforestry in Action webinar series, a production of the University of Missouri Center for Agroforestry. Please visit our website, centerforagroforestry.org, and to find information about future webinars and schedules, as well as to view recordings of past webinars, and also to visit all the agroforestry resources that are available on our website. So once again, thank you very much, and join us next month on December 18th for a webinar presentation by Katie Commender, the Appalachian Sustainable Development Organization, and she'll be talking about the Appalachian Herb Hub and their work with organizing with local producers there in Virginia and surrounding states for aggregation and processing of forest farm medicinal herbs. So once again, thank you very much. See you next time. Bye-bye.